Hello, everybody. It's Mr. Trochet with another video lesson. I don't know why I say that every time I start it, but I think it's kind of like my tagline or something like that. Anyways, let's get started. We have 7.1.5. I don't want to take too long. I want to get you in and out. And so let's go ahead and get started with our problem. We got 715, creating integer coefficients. Again, our coefficient is example 2x. 2 is our coefficient when it's 2x. So if it's 3x, 3 is our coefficient. If it's 4x, it's 4 is our coefficient. So remember that term. Coefficient means the number in front of the variable. Let's get started. How should we do this? Well, we have 7-51. And so what we're going to be doing is we're going to take a look at this. Apparently, we are painting apartments here. And there's a club that needs your help to determine how many apartments they should be able to paint in a day. Earlier this year, only 4/7 of the students worked, all right? And 4/7 of the students painted 9 apartments, all right? So 4/7 of the students got 9 apartments painted. Next week, all of the students were available. So let's start with A. Assume that all of the student workers contributed equally, as we know that never happens. Of course, always one person does a little bit more work than the others. But if X represents the number of apartments that can be painted by all of the students, so X is apartments painted by all students. Can't write there. Use a multiplier and represent this situation as an equation. All right, so before we had 4/7. Sorry, we have 4/7 of the students. Well, X is created by all the students. So 4/7 of X should equal 9. So we have, again, write this out. We have this is our students, which is 4/7 of X, which is our apartment per students, right? It's like apartments from all the students, and that should equal 9. So in order for us to solve this, we need to represent our answer in a certain way that's going to equal everything. So let's go ahead and solve for X. So I'm going to go ahead and clear the board. This is your equation. Right here, this is your equation. Write that down. And then what we have here is we have 4/7x equals 9. And what we do is we multiply by 7 on both sides. So if we multiply by 7 on both sides, this right here and this right here reduces down to 1 on top and on bottom. So we have 4x equals, and we got 63. Now, what we're going to do is we are going to divide by 4 on both sides to see what 1x equals. So this equals a giant 1. So it's 1x, 63 divided by 4. Well, let's just do this. 63 divided by 4. Let's see, that should equal 1. 4 equals 2, 3. So it's got to be 5, 23. Bring down the 0.0. And that looks like, so we're going to have 15. So we have 15 is our whole number. So 15, 30, 45, 60. So that's 60. We're going to have 3 left over. So this 3 is our fourth. That's just 3/4. And that's a little trick too. If you ever get your whole numbers, you can write down the whole number. And then what is remainder, you can put that on top of your fraction divided by 4. A little trick right there. So anyways, 15 3/4, which is going to equal, so X equals 15 3/4 or 15 7/5 apartments. So that's what that would equal. So that's our strategy. Another strategy you could do is you could do 4/7 X equals 9. And a faster way would be to multiply by the reciprocal of that, because the 7 and the 7 are going to reduce down to 1, and then the top 4, bottom 4 reduce down to 1. Just make sure you multiply the other one by that way too. So x equals 9 times 7, because you only multiply the top, is 63/4. And then you're done. Well, you have to reduce it, obviously, but you're pretty much done if it's 15 3/4. All right, moving on to 752. 752, let me just double check that's our problem we're doing right now. All right, 752. Janice, the club president, began to think how she can visualize 4/7 x. So she recalled using algebra tiles here, and x is represented here. So if you look, it's 1, 2, 3, 4. So we have 4 out of 1, 2, 3, 4, 5, 6, 7. So we have 4 out of 7 there. So x is 4 out of 7, and that equals 1, 2, 3, 4, 5, 6, 7, 8, 9. So that equals 9. So 4/7 x equals 9. That's what you're going to write. So does this equation represent your equation before? Yes. 4/7 equals 9. Why or why not? Well, it does because all the algebra tiles are pretty much equal to each other. So I would just say yes, because 9 equals 9. I mean, 9 is 9 right here. So the answer is still 9 and 4/7 of the x. So there's 4 shaded and 3 non-shaded for a total of 7 x tiles. And so that's the key, is that there's 7 x tiles, but there's 4 of them that are being used. And that's pretty much it. Let's move on to the next one. We have Janice recognized that these numbers were not easy to work with since she did not have whole tiles. After working on her paper, maybe I can make whole tiles using more than one sets of partial tiles. So then she drew this diagram at the right. So let me go ahead and move this over. And what we have here is now, what do we have? Well, we have 4/7 still, but there's 1, 2, 3, 4, 5, 6, 7. So now there's 7 groups of 4/7 x. So that means what is really happening? So what is our new equation represented in this picture? So there's 7 groups of 4/7 x. So that's pretty much what we're doing. And then what do we have here? Again, we have 1, 2, 3, 4, 5, 6, 7 groups of 9. So what we're doing is we are multiplying both sides of the problem. All right. So for C, with your team, which is going to be me, discuss Janice's strategy for solving the problem. Discuss this. What made Janice's strategy, and scroll up just a bit. There we go. What made Janice's strategy different than the one you did in lesson 7.14? Well, we used the reciprocal. We did the reciprocal. So instead of using 7/4, we were making the coefficient a whole number. So now we are making the coefficient more, no, not more, coefficient a whole number. Okay. How many sets of 4/7 x did Janet use? So she used 7 sets. All right. Why did the right-hand side of the equation change? The reason why that changed is because we need to keep both sides of the equation balanced. So you have to keep both sides. So if you do on one side, you do it the other. All right. And you got to keep it equal. All right. So you can say balanced or equal. Because if I just added 7 to multiply 7 on one side and you do the other, then it's way off balance. It's not equal on both sides. All right. And then the last one, we have this one right here. So how does the number of sets Janet used relate to the equation you wrote in A? So this one right here, which is this last question, is it's the same as the denominator. It's the same as the denominator. So how does the number of sets Janet's use? Because this is my 7, and that's what we use. That's what we use right there. All right, going on to the last problem, and then we are pretty much done here. So then the last problem is going to be, well, wait, which problem am I doing? We are doing, I just want to make sure, 774. Okay, 774. There we go. So Janice wondered if the method creating a whole number in X terms would work with decimals. Does it work with decimals? Suppose an item was marked off 50%. So this is the discount. And the sale was $36. So this is the sale here. And remember, the discount is 15 off. So that means our sale price is 85%. So that's where we're getting this 85, because 100 minus 15 equals 85. So if we're getting 15% off, that means we are paying 85%. 85% of what? Well, that's the X, and that's what we're going to go about. So why did she write 85 in her equation? Because that is the sale, or the markdown price, or the what you're going to pay. All right, so make sure you have that. If there is, so I'll write that down. I forgot what I said. It is the item is discounted by 15%. So the price is 85% of the original price. All right, that's what A is. This is what A is right here. All right, I'm going to go ahead and erase this. B, what do we have here? B here is there a number she can multiply both sides of the equation to get an integer coefficient? So there's no decimal. How can I get no decimal on this side? Well, that means I need to get this decimal moved over twice. How do I move a decimal over twice? I multiply by 100. Anytime you want to get rid of decimals, you multiply. So that means that this is going to move over twice. So that's 85x equals, and then that moves over twice too. 3, 6, 2, 1. If so, list at least one. All right, so that's going to be multiply by 100 on both sides. All right. Use Janice's strategy to solve the equation. What was the original price of the item? Okay, so Janice's strategy was that you just, well, what you do, creating whole numbers, yes. So Janice's strategy is we're going to use this times 100, so we're going to divide by 85 on both sides. So we have 3621 divided by 85. And that's a 0, 0. And then 300, 8, 16, 24, 32. Should probably be 4 times. That's 20, 32, 33, 34. So that's going to be 2, 2, and this is a 1. So that's probably going to be 2 times. 8, 5, 10, that's 10. Carry the 1. 8, 16, 17. So then that is going to be a 1, 22, 21, 20, 19, 18, 17, 5. And then point, add my point to 0. And so that's 510. 510, that should be 6. 6. That's going to give me a 30. So I'm going to write over here. So it's 510. So I'm bringing this over here. That's 30, carry the 3. 8 times 6 is 48. That works. 48 plus 3 is 51. Perfect. So that's 0. And then that's 42.6. So x equals 42.6. All right. What was the original price of the item? The original price was $42.6. Yeah. And you want to be making sure you're showing your work, everyone. You need to write all this stuff down. That's the only way you can use this for like your tests and your notes and stuff. All right. All right, so that's C. Let's go ahead and erase this and go to D. Does this method work for all equations with decimal coefficients? Yes, you can multiply a decimal by specific numbers. All right, you can do it by specific numbers. So this time was 100. So let's say, what if we wanted, I'll use this pink one. What if we wanted to solve 1.2x equals 14? So 1.2x equals 14, what do I multiply by? And you actually multiply by just 10, right? If you multiply by just 10, you move the decimal one spot, so that's 12x equals 140. So multiplying by 10. Multiply by 10. What if you wanted to do this 0.99 equals 712, so 0.999x equals 71.2. You multiply by 1, 2, 3 zeros. So 1, 2, 3 zeros, which is 1,000. 1, 2, 3 times 1,000. And that's going to equal 999x. And this is going to equal 712. 1, 2, that's a 0. And that's it. So I'll multiply by 1,000. All right. So that's pretty much it. Hopefully this didn't take too long. I hope you have a great rest of your day, and I will see you next time. Make sure you do your homework, and I'll talk to you tomorrow. Talk to you tomorrow or soon. And 17 minutes, not bad.